Alright, so in this program here, we're going to write the print function here, but I want to go back. I was reading through the datasheet more, and as I was practicing this before I created this video, I noticed that there's something that is a little bit misleading here on what these increment and decrement kinds of things are, entry, shift, and everything. So I'm going to go back to the H thing here and actually rename some of these to be a little bit more meaningful. This is actually entry left. Now what that means is new characters are to the left of the cursor. So we have to be careful. If we set that as entry mode left, then what that means is if we're in the home position, the characters we're writing are actually off the screen because they're trying to write them into the, if you want to think about it, they'd be writing them into the negative spots. And then this cursor shift is still okay, but by default, we want this off. And so basically, by default, we want both of these off. We want to be entering from the right, meaning that we want text coming in from the right side of the cursor, and then moving the cursor to the right. So we actually want both of those to be 0. And so with that here, of course, this is gone. What we actually do here for this, the initial setting we want for the entry mode is just the command function, because this will set this to be 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0. That's what this will do, which basically puts us in the entry right and the shift being 0. So I wanted to fix that. Otherwise, when you run through the program and we write our next function, the function will be 100% correct, but you won't see anything on your screen. Now, if we had those both being 1 and we had the cursor in a different location on the screen, you would be able to see the text. It's because we're starting with the cursor being at the 0, 0 location. All right, now we're going to write this function here. Now, one thing we need for this, in order to write it, I had to include one other library here, the string.h library, because we're going to be dealing with strings or character arrays, char arrays, sometimes people call them. They're just, I like to still use the word character. And so this, of course, is an array. And again, going to the data sheet here, going back to the data sheet, write a lot, because we have to be careful here. We said most of our commands are going to have these 0, 0s here, but not this one here. In order to write characters to the screen, the 0, 0s are writing instructions. You know, those are commands, instructions. I want to now write character data. So write data to either the CG or D DRAM. That's what I want to do, is I want to write data into either the D DRAM or C gram. And you can think of this as character, I like to think of it as character RAM or D DRAM. This is actually where like the character data is stored and stuff. But that's what we want to write our data to. And notice here that the register select is 1 and the read write is still 0. So what that means is it's going to mean that our write byte, our mode is going to be different. And so the mode here is going to be a little bit different. And so what we can do here is we'll say, all right, it's actually pretty easy here to do this. I'm going to create a couple variables here, unsigned int I, 8-bit, there we go, unsigned int 8-bit, and then I'm going to do another unsigned int 8-bit, and I'm going to call this length. Or actually, instead of length, why don't I call this size? And so what I want to know is, I want to know, because basically what I'm going to do is I'm going to print one character to the screen at a time. So I want to do size is equal to, I'm going to do a length, actually what is it, str, there we go. strlen for string length, and I'm going to do it on the word. So it's going to tell me how many characters are in that character array. So I'll know if there's 5 characters, 6 characters, whatever. And then I'm going to go ahead and just create a simple for loop here. So for I equals 0, because we're going to index at 0, of course, and I'm going to do it until I'm less than size, because if you think about it, if size returns 5, that means there's 5 characters in the array, but the location of those characters in the array would be at location 0, 1, 2, 3, 4. So I want this to be I less than size, then of course just an I++. And then inside this for loop, we actually are going to have a very simple command here. We're just going to do LCD. We're going to just write a byte again. And in this case, what we're going to write is we're going to write whatever character is stored in the byte there. But then I want to, the mode I want to be in is I want to still backlight, but then I don't want it to be R0 read write. I want RS to be 1. I want the register select to be 1 now. So that's the mode I want to put it in here, because this is the backlight being 8. This is the LCD underscore RS being 1. So now that's going to get me that 1. You might say, well, wait, what about the 0 you need there? It's by default going to be 0. I mean, if you wanted to, you could put another OR in here with it being a 0. But it's not necessary to do that. And so that writes a byte there. And actually, believe it or not, that's the end to our function there. What I also did here, I just want to put out here, is I commented out the LCD cursor set function just so that we don't have errors when we're compiling, because we haven't written that function yet. So I'm going to go ahead and go into my main C program here, and I'll just kind of go through here. I've written some code here, starting the I2C bus, initializing it. This is the address, 16 columns, 2 rows, font size 0. Then I start the LCD screen up, and I'm turning the blink on. You could also, here, I'll go ahead and do a pause here. For no other reason that you can then see, let's pause for 2 seconds. For no other reason than you can see that when you've initially started up, the cursor's not blinking, and then the blink will turn on, and then it will print out the classic hello. So let's go ahead. I actually have one here. I realized I had a device programmed into my computer already, hanging off to it. I've got too many things plugged into my computer at home. So I'm going to compile this. And mine just printed out the hello just exactly as it should. Now I'm going to go ahead and debug this just so that you can kind of see what's happening here. And then also, if you debug it, you'll be able to see how it's actually kind of writing each character. So let me go into the LCD program here, and let's go into and put a stop there. And well, actually, let's just put a stop on the right byte here. So if I hit go here, it's going to first pause, and now of course it's blinking and you can see the cursor. Now I can see here, if I look at some of these here, I look at I here, I is at 0, the size is 5. If you look at Word here, it's got 48 is what it's, because what it's looking at is the current, the first letter in it, or the first thing in this. I don't want to edit the value. What I want to do is see all of them. I don't know if there's a way here to see all values, because this is just showing the first entry of it. I mean, I could always look at the memory, and what I say by memory is I could look for, this is kind of fun, we could look for F7C. So F7C. And what's cool there is you can actually then see right here is the word hello written in the program, because that's of course what I had hard coded. So what I'm wanting to do is there's a 48 a 65, a 6C, a 6C, and a 6F. And what I'm going to do here, 48, do a search here, 48 ASCII value. Let's see if it's on the ASCII table correctly. If it's not, nope. ASCII, so it's not using ASCII here, apparently. Because 48 is corresponding to H, so it must be using a different kind of table to represent. Okay, here we go. Oh, ASCII and then hex. Yeah. Okay, so hex here, 48. That's what we're looking at. H. And then lowercase e, the hex would be 65, 6C, 6C, and then 6F. So it's using the ASCII table. Of course, it's using the hex value for the ASCII table, but that's where we get all these different symbols from. So that's why it's really easy, is you're literally just writing that data in there. Now, if I do a step over, H will now appear, and you'll notice that the cursor has moved off to the side one spot. And then we can see we get the H, the LL, and the O. Okay, so your next assignment, actually, you might have guessed what it's going to be already, is going to be to write a function that sets the cursor anywhere on the screen. So I'll give you a hint here. I need to go back to the data sheet. Because the way the code is written here is I'm giving you a column number and a row number. Now, the way it should be working is don't say column 1 through 16. Do column 0 through 15 and row 0 or 1. That's going to make it easier for you. Okay, that's the first thing. Actually, I don't know if it will make it easier, but that's the way I've done it in the past. And let me get to where I was going to show you. Oops, I went way too far. Okay. So the cursor or display shift is what you're going to want to be using here. And S is for display shift, but we're not really going to want to do the display shift. What we're going to be doing is cursor shifting. And so if we go to that cursor or display shift, cursor or display shift shifts the cursor position or display to the right or left without writing or reading display data. Table 7. This function is used to correct or search the display. In a two-line display, the cursor moves to the second line when it passes the 40th digit of the first line. Note that the first and second line display will shift at the same time. When display data is shifted repeatedly, each line moves only horizontally. The second line does not shift into the first line position. And then it does something else here. So let's find table 7. So here it has the shift function here. So SC being 0 and RO being 0 shifts the cursor position to the left. Shifts the cursor position to the right. Shifts the entire display to the left. Shifts the entire display to the right. And then it says the cursor follows the display shift. Now, when we're doing the set cursor position, you're really going to be wanting to move the cursor left or right. Now, one way to do that is, an easy way to do that is to basically use some logic. Start with your cursor, just automatically put it to home. If you send your cursor to home, it doesn't clear the display, it just puts the cursor to home, so you know precisely where that cursor is now. So you know it's at location 0, 0. And now, based off of what's been inputted into the function here, what's been inputted into this function, you can now increment whether you want it to be in the correct column or the correct row. So let me give you another hint here. So my hints for this is to first do an LCD home. Because, or return home, I think is what the command was that we called it. Return home is what we called it, wasn't it? Or did we just call it home? I can't remember what we called it. No, we just called it home. So this will move cursor to, and actually you could, honestly you could have it be, if you wanted to do 1 through 16 and 1 to 2, that's fine. I like the 0 to 15 and 0 to 1. This is going to move the cursor to location 0, 0. And I like to, even though it's kind of backwards, I'm going to follow the way it has here. Column 0, row 0. Now then the next thing I would do is see what row you need to be in. And why? Because if we go back to the data sheet, when we looked at this cursor shift, it says in a 2-line display, the cursor moves to the second line when it passes the 40th digit of the first line. So if you know you're going to need to be in the second row, like if you're going to be in the second row, line and like column, 4 or whatever, well, first just shift 40 digits, go home first, then move 40 digits to the right. That gets you to line 2, and then just move to wherever you need. So hopefully that's clear on what I'm saying as far as my hints, but your next assignment, which is going to be due next week, or actually I guess it's this week or whatever, because I forget when I post the videos and when you're watching them. So saying next week or this week is probably a bad thing to say, because it's due corresponding to the due date, is going to be to write a function that allows us to move the cursor to any location on our screen.